Hello and welcome to another episode of Earth911's Sustainability in Your Ear. I'm Mitch Ratcliffe, and we're back to have another conversation with a difference maker, a pioneer of a new way of life that will be easier on the planet. And today we're going to talk about water. Water is life. It's also one of the primary elements needed for manufacturing. And of course, we use fresh water to support every aspect of our daily life, including carrying away our sewage. The U.S. Geological Survey estimates that Americans consumed 322 billion gallons of water a day during 2015, the last year for which data has been reported. And now here's an important, and it's a positive fact. As a nation, we have used 9% less water between 2010 and 2015. So there has been some progress in water use efficiency. Stewardship of our water supplies, however, will be key to our becoming a sustainable society, because the United Nations warns that the world faces up to a 40% shortage of water by 2030. We're joined today by Prakash Govindan, who is the co-founder and chief operating officer of Boston-based Gradiant, a global clean tech water technology provider that offers post-industrial water and wastewater treatment technology to large companies around the world. They recently raised an additional $100 million in venture capital to accelerate expansion, particularly in Asia, where Prakash is speaking to us today from Singapore. Asia faces continued post-industrial wastewater challenges. We still need to clean up a lot more of the water being used in manufacturing in Asia before it's released back into the environment or reused. So let's open the tap and learn how clean tech water technologies can help preserve water for human use and to be left in nature to support other species. You can learn more about Gradiant, which is spelled Gradiant, at www.gradient.com. Welcome to the show, Prakash. How are you today?
Hi, Mitch. Thank you so much for inviting me and having me. I am very excited to talk to you and your very knowledgeable audience.
Well, thank you. And it's a pleasure to have you join us. Now, we hear a lot about the idea of a circular economy, and what your technology makes possible is a closed loop of manufacturing use of water, so that they simply reuse the same water over and over instead of pulling more from freshwater sources. Tell us, how has that process of moving from the old way, where we just 50 years ago dumped untreated sewage into water, to an environment today where we are actually concerned about reusing water rather than dumping it?
Great question, Mitch. Yes, it is very, very possible to reuse a lot of water, both sort of domestic consumption, which ends up as sewage, but more importantly, industrial consumption, which ends up as high contamination waste. So if you look at the US, around the country, there are several Superfund sites, both soil and water. And if you track the history, and the US government does, of these Superfund sites, which are highly contaminated sites around the country, you will notice that the soil sites are all almost fully remediated, whereas water, once it's contaminated and stuff gets in groundwater, it becomes very, very hard. It takes decades to fully clean it up. So it's very important to avoid that contamination on the one side, but at the same time, it's also very important to reduce the reliance of industries such as semiconductors, such as pharmaceutical industries, such as textiles and others, power plants, mining and refineries, and others, on the locally available fresh water. So what Gradient does is exactly like what you described. We cut off the contamination by taking the wastewater into our end-to-end integrated hardware solutions, systems, water treatment systems, and we produce high-quality water, which can then be reused within the industry, so that the industry doesn't have to source from waters which would otherwise be used for domestic and other consumption.
So we used to use the water and dump it back into nature 100% of the time. How much water can be reused? Is there loss in every cycle of water reuse, or can you literally recover 100% and reuse it?
We can recover a very large percentage. A lot of gradients plants around the world. We have more than 40, 50 plants that we have deployed as a company since our inception. They recover more than 99% of the water. So almost all of the water. I mean, thermodynamically, there is diminishing returns in trying to recover more than that. And also there are contaminants which have to be disposed of in one form or the other responsibly. Mm-hmm. So 99% is a good goal to have.
That is an amazing statistic, the idea that we could reuse that much. Now, are you doing this both in industrial settings and in water treatment facilities for municipalities, or just in industrial settings at this point?
So historically, Gradiant has done a lot with industries. A lot of our clients are Fortune 100 industries who are producing, some of the, all of the commonly used substances, from semiconductor chips to the drugs we consume, to the petrochemical products, to the minerals that we use, including. There's been a lot of news recently around nickel and cobalt and the prices around them, all of those industries. But we also, as an example, outside of LA, in a suburb, we are working with the local municipality to recycle their sewage. So we take treated sewage and we purify it to a level where it can be injected into an aquifer.
Okay, so you're actually restoring the groundwater with treated water from the sewage system in LA. That's really interesting. Now, thinking about the way that we currently process waste water from domestic consumption or residential consumption today, is there a path to beginning to restore aquifers in places like California simply by reusing the water that we produce as a society, or should we think more about keeping it out of the ground and just reusing it? Which is more efficient?
The low-hanging fruit of increasing the efficiency there is working with industries, in our view, because California is the example you quoted. They have a lot of industry, all kinds of industry, and working with these industries to increase their water efficiency to the level that I described previously, where almost all of the water is reused within the industry, that will cut off the freshwater withdrawal by these manufacturers and other kinds of industries. Because at the end of the day, domestic consumption is only a fraction of the total fresh water that is being withdrawn out of the water system, including groundwater. Industrial consumption can be quite significant also. Of course, we can also work with municipalities more and more to reuse domestic consumption. That, I would say, is the next step. Singapore is a good example, Mitch, in this regard. They have 4 taps, so to speak, that they reuse at the national level. They have the water that they catch from their rains, the local catchment water. They have imported water from Malaysia, which they are increasingly not reliant upon. But they have, very interestingly, the final 2 taps, national taps, is new water and desalinated water. New water is what you're talking about, Mitch, which is they take all kinds of wastewater, sewage, domestic waste, industrial waste. They segregate it and they treat it in centralized plants where they produce high purity water, which then goes into the aquifers. And they also have desalinated water. So Singapore is an island surrounded by ocean, and they take the Indian Ocean water and produce drinkable water from it. A similar model could easily be adopted in other places in the world, including California and other states in the US.
Yeah, I think especially island nations who, ironically are surrounded by water, but often run short of water are where we're going to invent a lot of these solutions. And another island that has an immense amount of industrial activity is Taiwan. Can you tell us how water is used in several industries? Because I don't think folks really think about how much water we use, sometimes even as a solvent in its most pure form. How do we use water, for instance, in semiconductor manufacturing?
Oh, great question and great example of Taiwan. I'm glad you brought that up. Significantly more than 50% of the world's semiconductor chips are produced in Taiwan, and Taiwan's semiconductor industry, which is led by TSMC, Taiwan Semiconductor Manufacturing Corporation, is facing a business continuity issue, and of course an environmental sustainability issue, where a large, significant portion of the total freshwater withdrawal from the Taiwanese water system is being consumed by the semiconductor industry. So sustainability and business continuity are huge factors in them adopting circular economy solutions that Gradiant and companies like us have to offer. So that's an important piece of consideration. Any given manufacturer, for example, and recently in the US, the federal government has announced billions of dollars in grants to companies like Intel and Micron, which are foundries, and there's going to be chip manufacturing facilities put in Idaho and Ohio and places like that, where
in Texas as well. Samsung's building a plant in Texas.
Yes, correct. So increasingly there's going to be similar issues to Taiwan in the US. So this is not just somebody else's problem. This is our problem in our backyard. And each of these foundries, you talked about water consumption. They withdraw up to 10 million gallons of water a day from the water table.
Really?
Yes, correct. And this is then further treated to be high purity water, which comes in contact with the chips and different components throughout the fabrication process. And as a result, it takes contaminants into itself, difficult to remove contaminants, and various kinds of wastewater streams are produced. So what Gradient does is, we go to these industries, and we have built several plants now in semiconductor, and we take the wastewater, we segregate, we treat, and we produce high purity water, which is then further treated into ultra pure water, which can be used within the industry.
So if hypothetically they're using 10 million gallons of water a day at a foundry, and they run your technology, does that mean that they move from 10 million to 100,000 gallons of water because they're able to recover 99% of it?
So there are various kinds of contaminants, right, Mitch? So there are organic contaminants. An example would be isopropyl alcohol, which is used in chip manufacturing and enters some of the wastewaters. And there are soluble salts, like common salts, which are not dissimilar from what is in seawater. So depending on the proportion of the different wastewaters which contain these different contaminants, we could reduce their freshwater withdrawal from 10 million gallons down to 100,000, somewhere in the range of 100,000 to 1 million gallons per day.
Another industry I wanted to ask about, because again, I don't think folks really understand how much water is involved in it, is the textiles manufacturing industry. Tell us how making cloth and clothing involves the use of water, and how much water. Do you have a sense?
Yes, of course. Textile manufacturing is quite water intensive. Dyeing is an example. Dyeing operations are mostly done using aqueously soluble dyes, natural dyes, synthetic dyes, a hybrid of those. And in order for the dyes to really enter the fabric and stick on, you tend to need to add salts into it. And an example is blubber salt, which is sodium sulfate salt, is added into it. So the at the end of the process, you're left with this relatively highly saline, highly contaminated wastewater, which you have to treat over a series of steps. And what Gradient does is, I typically say around 1 million liters a day level treatment facilities, somewhere between 1 million and 10 million liters a day of treatment. We put down end-to-end hardware solutions, water treatment plants, which first remove the dyes and then remove some of the more hard to remove soluble components. And then we concentrate the water using our reverse osmosis infinity technology, where we extract fresh water out of it. So fresh water is the first product which is then reused within the dyeing factory. And then the leftover concentrated brine is crystallized to produce salts. And we are able to preferentially produce pure salts, blubber salt, which is then again reused within the industry, reducing the environmental footprint of the industry. And a small amount of salt is then disposed responsibly back into the environment.
Thank you for explaining that, because that really brings home how much we can increase our optimization of the production of virtually everything. One of the things I wanted to ask about, after reading your funding announcement, I noticed that your strategy is to acquire incumbent water management companies to gain access to new regions. And the question that occurred to me is water at this point largely locked up in long-term contractual relationships? And how does that prevent us from innovating more rapidly? Because you would have to purchase the facility before you could begin to innovate.
Great question. So Gradient's intent in acquiring companies is, we are not a private equity or anything like that. We don't acquire to increase our top line. We acquire for obtaining paths to market. So we have these really good mix of hardware and digital solutions, which can really make a huge dent in terms of reducing the freshwater withdrawal, reducing the environmental footprint of our industrial clients. And as a company which is only 9 to 10 years old, we are not everywhere. So we buy companies which have a track record working with local industries in regions we don't have, and we then layer on our technology, our people, our ability to fund build, own, operate projects, and we grow those companies that we acquire locally as part of Gradient. Long-term concessions is a great point again, Mitch. I love your line of questioning, by the way, not to flatter you, but these are very important questions. The value of water is a big problem today. Industries, but also domestically as individuals, citizens, people, we see water as a free commodity, which is the farthest thing from the truth. There is a lot of capital and operational costs that are hidden, that go into maintaining our water systems, maintaining the high quality of water that we take for granted around the country, in the US and other developed parts of the world today. So
that's a critical point. If people knew the true price of a gallon of gas, because of all the incentives that are behind it, it's at least $12, if not $25. But water, we think in terms of pennies per hundreds of gallons, basically, and it's not true. So as you mentioned earlier the fact that there are a lot of new policies and programs in place to help reduce industrial water use. How does Gradient work with its customers to create financing for new water projects? Are you taking advantage of more incentives and tax breaks that are going up as we try to address this problem?
We don't have any government subsidies that we have taken advantage of.
Really?
There are a couple in terms of R&D funding. In the U.S., USBR, Bureau of Reclamation, uh, has funded a couple of our R&D initiatives, which we are grateful for, very helpful. But in addition, in Singapore, also the Economic Development Board has funded some of our R&D. But in terms of projects, these projects are funded by banks and private equity on the back of the economics. Not only can we secure our clients' future in terms of continuity of business, not only do we increase their sustainability profile and make them more environmentally viable, but we save them money, Mitch. This is what gets lost in the message, is they have to pay money right now to source water.
Right.
They have to pay money right now to dispose water. They have to pay fines to the local EPAs around the world because they are contaminating stuff. And they also get significantly negative PR. And if you calculate the sort of life cycle cost of their water, we are typically half of, if they pay half the money of that and give us a long-term concession, we make money and they save money. So the economics is also good.
Across the board, green economics do tend to end up being very positive, but you have to take a long view. Do investors and individual companies tend to be focused on the next few quarters, or are they really thinking 10, 20, and 30 years out?
In terms of Gradiant and its investors, we take the long view because one of the three ways we make money is build, own, operate, where we not only have technology that we invented, we design and we fabricate them, but we own and operate the equipment over a long concession period with our large industrial clients. So we take the long view on that, and over a period of a few years, we pay back on the capital, and then after that, we make money. Our industrial clients don't have to take that view when they use Gradiant, because initially they don't have any capital investment. And from day one, they are saving money on us because we are producing water for them and taking care of their wastewater at the same time at a 50%, for example, of the cost that they have today.
Let's talk a little about the water supply. The United Nations has predicted that we're going to face 40% freshwater shortages by 2030. Do you see that coming to pass, or do you believe that we are improving our water use efficiency to such a degree that we might avoid that crisis?
That is a difficult target. The way I see it, Gradient sees it, the low-hanging fruit with respect to hitting that target is actually the municipal side, ensuring water that's being stored doesn't have biological buildup. This is especially in the developing world, and is properly transported to the end user, ensuring that rainwater is harvested around the world, and ensuring the contamination of already available bodies of water and groundwater is avoided. So that's the low-hanging fruit of making sure a large part of that UN 2030 target is hit. But at the same time, in order to fully hit that target, having circular economy with industries is very much part of the picture. And the way we see it today, we might miss that target if there is not more done from the part of governments to encourage this kind of activity via regulations, which make it harder for industries to operate withdrawing large amounts of fresh water.
So the solution to avoiding the 40% shortage is both more reuse and treatment of municipal water so that we're not drawing as much, increased efficiency, the reduction of water draws from nature by industry, and more reuse. And it sounds like really one of the variable that we don't have complete control over is the value of water. And how do we as we think about water as a commodity, which it clearly is, how do we ensure that the poor, the low-income people around the world are going to have access? Do you have any thoughts on that?
Great question. When I did my PhD at MIT, I did work a lot with emerging economies, underserved, underdeveloped parts of the world. So I am very sensitive to that specific problem. As water becomes a commodity and the price of water rises, what we have to understand is the large consumers like the industries, for example, the 10 million gallons per day in a chip foundry, right? That if you have a price of water which is even 30 cents per 1,000 liters of water, that amounts to a lot of money, and that cuts into the bottom line of that particular foundry. Whereas if you translate that to human consumption, the humans consume several gallons a day of water directly and indirectly. For example, in the US, an average person consumes around 100 to 150 gallons a day of water. So it's a much, much lower level of consumption compared to 10 million gallons a day per person. So even at the lower end of the economic strata, where persons are making only say $10 a day in salaries or income, they won't be affected because at the prices that I mentioned, which is say 20 to 30 cents per 1,000 liters, because their consumption is so low, it would be a small, it would be a fraction of a percentage of their expenses otherwise.
So another thing I hear is a subtext to what you just said is because of the water use that you referred to, personal water use, a lot of that 100 to 150 gallons is raising the food we consume. So if we're more efficient in our use of water or ate less beef, which is responsible for an immense amount of water consumption as well as pollution, that would be another way to lower the burden and therefore make this resource available to everyone.
Exactly. Yeah, I myself am a vegan. You can't preach without practicing. So you hit the nail on the head there with respect to individual water consumption. The largest item is the food we consume. So being more conscious of that, both from a carbon dioxide that we put in the air perspective, but also not often talked about the water consumption perspective. Very important. Great point.
So let me ask as we close out the conversation, what do you imagine the water infrastructure will look like in 2050? Is it completely circular? And the other question is, who's going to be in control of it? Will it be a public resource, a private resource, or a mix?
So the municipal water infrastructure has seen tremendous growth and is one of the largest achievements of the human race over the last century. However, water recycling has not caught up due to evolving valuation, perception of value that we discussed previously of water. So from Gradient's point of view, 2050, we would like to see the current consumption of industrial water, in that I mean the freshwater withdrawal, to drop to less than 20 to 25% of the current levels. And one thing we see increasingly becoming a large part of the infrastructure is digital solutions. Mm-hmm. So we have, for example, and other companies do too, we have smart ops, which is our digital twin to our hardware integrated offering that Gradient is known for. So that helps us maintain the assets. It helps us actively optimize and bring into the industry 4.0 infrastructure, existing water treatment assets and new water treatment assets that we put down. So digital is going to be a huge part of the infrastructure going forward.
Yeah, monitoring and measuring is the key to our becoming a lot more efficient. I absolutely agree with that. Prakash, how can folks follow along with what Gradient's doing?
Gradient.com. That's gradient with an ant. So Gradiant.com. We would love to hear from your listeners. Our customers are large Fortune 100 companies, but in raising the awareness around the value of water, every person, every citizen has a huge role to play in the US and in other places. Please follow us on LinkedIn. We share latest industry news, events, trends. So again, Gradient, Gradiant.com. Thank you.
Prakash, thanks very much for spending some time with the Earth 911 community today.
Thank you, Mitch. This has been a pleasure.
We've been talking with Prakash Govindan. He's the co-founder and chief operating officer at Boston-based Gradiant. It's a global clean tech water technology company. And I think that was a fascinating conversation for this reason. We got into how water is being used behind the scenes to make most of the products and services that we rely on viable for all of us. And if you think about, for instance, the use of water in your textiles manufacturing, the clothing you buy, every time you pull a new item of clothing off the shelf, you're talking about gallons, sometimes hundreds of gallons of water being used to produce it. So making your clothing last longer, buying a little less and using your clothing longer is better for the planet. Maybe you're not as fashionable, but what is fashion if it doesn't represent your values? And our values, I think, folks, need to be about the planet and the climate that we are living in. This is Earth 911, Sustainability in Your Ear. We, of course, will be back with another innovator interview soon. In the meantime, I hope you'll take a few minutes to share this podcast, particularly the issues about the water use, with your friends, your family, coworkers, particularly your coworkers. Stop at the office and ask everybody whether or not they're taking the environment into account in the decisions they're making about what your company, your business, the government that you work for, whatever it is. Are you taking the planet into account when you make business and operational decisions? That's the key to sustainability that we need to unlock for all of us. We'll be back soon. In the meantime, folks, take care of yourself, take care of one another, and let's all take care of this beautiful planet of ours. Have a green day.